Hi everyone, this is part 2 for lesson 4.2 to complete those extra proofs. So we're going to do the 8-step proof first, and then I'm going to ask you to pause so you can do the top one by yourself before I show you the answers. So this 8-step proof is a little more complicated than the other two that were in the other video because they don't tell us very much. Well, they give us 3 things, but it's not necessarily what we're looking for, because what ideally we would have is that we have proportional sides or 2 sets of congruent angles, and we don't really have that. So let's start by marking our givens. So they told us that FG is congruent to GH. So what kind of triangle is that then if we have 2 congruent sides? Good, it's an isosceles triangle. So remember, we have all those special properties, theorems, postulates about isosceles triangles. So our next given says that JK is congruent to KL. Oh, shouldn't have 2 marks because they're not congruent to that one. So again, we have another isosceles triangle. And then the last thing that they gave us was that angle F is congruent to angle J. So we want to prove that these triangles are similar. Okay, so if we think about our 3 ways to prove triangles similar, angle, angle, side, angle, side, and side, side, side. For those side, angle, side, and side, 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 we need to have proportional sides. Did they tell us that we have proportional sides? No, they didn't. They did tell us that we have 2 congruent sides in this triangle and 2 congruent sides in that triangle, but they didn't necessarily tell us proportionality across. We could try to work with that, but it would take a lot more steps and it would be a lot more difficult than the way we're going to do it. But they told us that we have 1 angle. And what do we know about the base angles of isosceles triangles? Well, we know that they're congruent. So that means that angle F is going to be congruent to angle H. And angle J is congruent to angle L. But one of our givens said that angle F is congruent to angle J. So if F is congruent to H and F is congruent to J, what does that mean about H and L? Well, that would mean that they would be congruent. So we would end up having these 2 congruent and these 2 congruent. So how are we going to prove that these 2 triangles are similar? Very good, by angle, angle. But as you can see, it's going to take 8 steps to get there. So the first thing we need to do is state our sides. So we have that FG is congruent to GH because it was given. JK is congruent to KL because it was given. I'm not going to state that my other sides were congruent yet because, I'm not going to state that my angles were congruent yet because we're not going to use that till the end or towards the bottom. So I'm going to save that given for later. So remember what we talked about. If these 2 sides are congruent, what do we know about the triangle? What kind of triangle is it? It would be isosceles. So triangle FGH, and this one's also isosceles. Triangle JKL are isosceles because of the definition of isosceles. So if we have isosceles triangles, what did we know about this one triangle? What was the main thing that's important about it? Well, isosceles triangles have congruent base angles. So I can say that angle F is congruent to angle H because of the isosceles triangle theorem. Remember that told us that we have congruent base angles in isosceles triangles? So in this one, we've got the same thing, or not the same exact thing, but that the base angles are congruent because of the same theorem. Okay, so Have I stated any angles congruent from triangle to triangle yet? Nope, and that's what my last two steps are for. So we were given that angle F is congruent to angle J because it's given. So first angle on our checklist. So we need the next angle, and we kind of talked about already what angles it's going to be. What angles are congruent now? Angle H and angle L. But why? Why is the key word here? How do we know that those two angles are congruent? So I'm sure, maybe, hopefully you're thinking transitive property, and it's not quite transitive property because the transitive property told us that if A equals B and B equals C, then we would have A equals to C. So how many variables do we have in the transitive property? There's 3 different variables there. But if we take a look here, how many variables do we have? There's 4. So it actually doesn't work out to be transitive, but what was that other property that was a lot like transitive? And I said sometimes it's okay if you use one or the other. Substitution property. Good. So those are congruent by substitution property. So if we take a look at this statement, so we had that F is equal to H. So if I take this H and plug it into that F, there's where my H came from. And then here we have that J equals L. So if I take that L, plug it into J, there's where my L comes from. So we just took those two things, L and H, and plugged them into where they're equal to get that H is congruent to L, which was our second angle, which makes those triangles similar. So go ahead, pause your video, and try the last proof, and I will show you the answer when you come back. Okay, so I hope we did well on this last proof. So this one is really similar to the second one that we did in the other video. They told us that we have parallel lines. So remember, parallel lines makes all of our awesome congruent angle pairs. So if we make our Z, we have C and M congruent. And then if we make our Z the other way, we have A and P congruent. So the triangles would be congruent by angle-angle similarity. So thanks for watching. Warner out.